Hello everyone. On this video we will be looking at the derivatives of the trig functions sine of x and cosine of x. Alright, so first we'll look at the derivative of sine of x. Okay, the derivative with respect to x of sine of x is equal to cosine of x. And 2, the derivative with respect to x of cosine of x is equal to negative sine of x. Okay, so we're going to prove the first one, and proving the second one is pretty similar to it. So I'll let you go ahead and do that. Okay, so if we have proof of 1, derivative of sine x equals cosine of x. Okay, now to do that, we do have to remember the special limits rather for trig functions. The limit of sine of x over x as x approaches 0 equals 1, and the limit of 1 minus cosine of x. I'll put that down below since I'm running out of space. Or better yet, I'll just put a comma. And the limit of 1 minus cosine of x all over x as x approaches 0 is equal to 0. Okay, so those are our special limit functions for trig identities, well, at least those two special limit functions. And of course, they'll be proven later. But for right now, you have to remember those in order to differentiate your sine and cosine. Okay, but we're going to do sine. Okay, so if we have the derivative with respect to x of sine of x, remember the derivative is just using the limit function. So that's the limit of sine f of x plus delta, or x plus h, so that's sine of x plus h, minus your f of x, which is sine of x, all over h as h approaches 0. Alright, so now what we're going to do is we're going to change up that sine of x plus h. Okay, so using the sum formula from trigonometry, you can all kind of look that up. Okay, so sine of x plus h is equal to sine of x cosine of h plus cosine of x sine of h. Okay, and remember that comes from the sum formula for trigonometry, where sine of a plus b is equal to sine of a cosine of b plus cosine of a sine of b. Okay, so we're just using this as kind of like a way to stretch that out a little bit. So instead of having 2 terms for your sine, you're only going to have 1. Okay, so you have, that's equal to, just kind of keeping up from there, the limit as h approaches 0 of sine of x cosine of h plus cosine of x sine of h minus sine of x all over your h. Alright, now what we're going to do is we're going to kind of move these around a little bit, because what I want to do is I'm going to move sine of x, cosine of h, move those next to each other. and factor out a negative sign. Okay, so that's going to equal the limit as h approaches 0. If I move that minus sine of x to the front, if you have minus sine of x plus sine of x cosine of h, then that would just be minus sine of x okay. So we have, actually it'll be a little bit easier to leave that where it is, only because we're going to switch that around. So what I'm going to do is just move that closer to that one. So you have cosine of x sine of h plus sine of x cosine of h minus sine of x all over h. Okay, so just move, instead of moving the minus, just move the plus over. Okay, so now we're going to factor out minus sine of x from these two terms. Alright, so what that gives us is the limit as h approaches 0. We have cosine of x sine of h over h. So if we get the cosine x and just bring it out to the front, so we have cosine of x times sine of h over h. Okay, and if we factor out the minus sine of x, that will end up being minus the limit as h approaches 0 of sine of x times 1 minus cosine of h over h. Alright, so again, if you get the minus sine of x and distribute it to those two terms, you'll end up back with those two. You have the minus sine of x plus sine of x cosine of x. So that's why I just factor out the minus sine of x. Okay, so now using the limit properties, I'm going to go ahead and just distribute the limit to both of those factors. Okay, so for this one, you have the limit of cosine of x as h approaches 0. So the limit of cosine of x as h approaches 0 times, I'll just put the little times there, the limit of sine of h over h as h approaches 0. Sine of h over h as h approaches 0. Okay, minus the limit of sine of x as h approaches 0. Limit of sine of x. Oh, why did I put that up there? The limit sine of x as h approaches 0 times the limit of 1 minus cosine of h over h. The limit of 1 minus cosine h over h as h approaches 0. Okay, so now we have everything set up that we need. The limit of cosine of x as h approaches 0, there is no h to replace using direct substitution, so really this is just cosine of x. Okay, limit of sine of h over h as h approaches 0. Remember, we have the limit of sine of x over x as x approaches 0 is equal to 1. The variable itself really doesn't matter. As long as it's in the same format, here you have sine of x over x, here you have sine of h over h, here you have as x approaches 0, as h approaches 0, so it matches up. So you see here, that's times 1. Minus, you have the limit of sine of x as h approaches 0. Again, no h to replace, so you have sine of x. And here, same thing with sine of x over x. You have 1 minus cosine of h over h. As h approaches 0, here you have 1 minus cosine of x over x as x approaches 0, equal to 0. So you have sine of x times 0. Okay, so this disappears. 0 times anything is just 0. So you end up with cosine of x times 1, which is cosine of x. Okay, so the derivative of sine of x equals cosine of x. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and knock out a couple of examples. Whoops. Straighten up my paper there. All right, so let's say, for example, we want to find the derivative of, say for problem A, we have f of x equals 2 times sine of x. Say for problem B, we have g of x is equal to sine of x over 2. And let's say for problem C, we have h of x is equal to x plus cosine of x. All right, so to solve those, starting with problem A, f of x is equal to 2 sine of x. Okay, so that means that f prime of x is equal to 2 times the derivative of sine of x. So in other words, f prime of x is equal to 2 times cosine of x. All right, so for problem B, pretty much the same thing. But g of x equals sine of x over 2. All you have to do is just make that g of x equals 1/2 times sine of x. Okay, that means the derivative, g prime of x, is equal to 1/2 times the derivative of sine of x. Oh, close that up. There we go. So that means your derivative is equal to 1/2 times cosine of x. Okay, so it's the same approach for C. Okay. But the only thing is here you have to look at each individual term. Okay, so h of x, which is x plus cosine of x, we know that the derivative is the derivative with respect to x of x, that first term, plus the derivative with respect to x of cosine of x. Okay, so your derivative is equal to the derivative of x is just 1, plus the derivative of cosine x is negative sine x. So your derivative is 1 minus sine of x. Okay. Alright, so if you are still writing, feel free to press pause. But we're going to go ahead and look at another example. Why does this keep sliding up? Straighten up my paper again. Okay, so let's say, for example, slide that over, there we go. What if we want to find the derivative of, say, f of x equals negative cosine of x plus sine of x. Kind of straighten out that s a little bit. At the point x equals negative pi over 2. Alright, so what I want you to do is I want you to go ahead and press pause and try to solve this one on your own. Alright, so I'm assuming you've already pressed pause and worked this one out. So let's go ahead and verify your answer. Okay, so if your f of x is negative cosine of x plus sine of x, that means your derivative is equal to the derivative of your first term. So the derivative, actually what you could do whenever you have a negative, you can just factor that out as a negative 1. Okay, so I'm going to go ahead and do that. Okay, so f prime of x is equal to negative 1 times the derivative of cosine of x. So put that on the wrong side. Times the derivative of cosine of x plus the derivative of sine of x. Okay? So that means your derivative is equal to negative 1 times the derivative of cosine of x is negative sine x. So negative 1 times negative sine x plus the derivative of sine x is cosine of x, which gives us the derivative equals sine of x plus cosine of x. Alright, so we found our derivative. We just have to find it now at the point of negative 5 over 2. Okay. So when x is equal to negative pi over 2, f prime of negative pi over 2 is equal to sine of negative pi over 2 plus cosine of negative pi over 2. Okay, so that's going to equal sine of negative pi over 2 is negative 1 plus cosine of negative pi over 2 is 0. So your f prime negative pi over 2 is equal to negative 1. Alright. So if you are still writing, feel free to press pause. But we're going to go ahead and work on the next example. Okay, so for example, what if we wanted to find the derivative of, let's say, f of x equals negative 2x to the third minus x squared plus x minus 2 times cosine of x. Alright, so working on this one, we're going to actually apply the product rule to this one. Okay, and that product rule, if you remember, is the derivative with respect to x. If you have two functions multiplied to each other, so you have f of x times g of x is equal to the first function times the derivative of the second plus the second function times the derivative of the first. Alright, so that means I'm just going to rewrite our function. Equals negative 2x to the third minus x squared plus x minus 2 times cosine of x. Okay, so if you want to use this formula and you're confused, you can change this to h of x if you want to, or you can just say the first and the second. It's all just a matter of what makes you comfortable. Okay, so just the fact this is f of x, you can use different variables there. Okay, so here, this is your first function and this is your second function. Okay, so that means the derivative of that is going to be the first, negative 2, let me bring that down a little bit so I don't run out of room. Just going to bring it over just a hair. There we go. So f prime of x is going to equal the first. So you have negative 2x to the third minus x squared plus x minus 2. Clean that up a little bit. There we go. Plus x minus 2 times the derivative of the second. So times derivative cosine of x plus the second, which is cosine of x, times the derivative of the first. Negative 2x to the third minus x squared plus x minus 2. Okay, so you have the first function times the derivative of the second plus the second function times the derivative of the first. Alright, so now let's go ahead and simplify those. So that's going to equal, you have the first, negative 2x to the third minus x squared plus x minus 2 times the derivative of cosine is negative sine of x plus cosine of x times the derivative of negative 2x to the third minus x squared plus x minus 2. Okay, so we go ahead and find the derivative of each of those terms. So we bring down the 3, that will give us negative 6, and subtract 1, so that's x squared, minus, bring down our exponent, that's 2x. Derivative of x is just 1, and derivative of a constant is 0. Alright, so really none of these would be combined because they would not be the same, so you couldn't combine cosine negative 6 x squared cosine x with, let's say, sine x times x squared. You couldn't combine those two. So this, you can probably just simplify it a little bit, but for the most part, this is as far as your answer would go. So you have cosine of x times negative 6 x squared minus 2x plus 1, okay, minus, say, negative 2x to the third minus x squared plus x minus 2 times sine of x. Okay, and of course, like I said, there are different ways you can present this answer. If you wanted to distribute your sine and cosine, you could. You just probably won't have to. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. All right. So if you wanted to find the derivative of, again, let's say f of x is equal to negative x to the third minus 2x squared minus 2x times sine of x. All right, so what I want you to do is go ahead and press pause and try to work this one out on your own. Alright, so I'm assuming you've pressed pause and you've already worked this one out. So let's go ahead and verify your answer. Okay, so you have two functions being multiplied to each other. So that means we're going to use the product rule. Okay, so remember the derivative, instead of f of x and g of x, I'm just going to put, I'll just write it out, f of x, g of x equals your first function times the derivative of the second plus the second function times the derivative of the first. Okay, so that means our derivative here, f prime of x, is equal to our first function, negative x to the third minus 2x squared minus 2x times the derivative of the second plus the second function, sine of x, times the derivative of the first. Negative x to the third minus 2x squared minus 2x. Alright, so that is going to equal, you have negative x to the third minus 2x squared minus 2x times the derivative of sine x, which is cosine of x, plus your sine of x times the derivative of negative x to the third minus 2x squared minus 2x. So if we bring down that 3, we'll end up with negative 3x and subtract 1 from that exponent, so 3x squared, minus, bring down that 2, 2 times that 2 would be 4, subtract 1 from the exponent, that's x, minus 2 times the derivative of x. The derivative of x is just 1, so that's 2 times 1, or just 2. Okay, and once again, you can't combine anything if you distribute here, so this ends up being your actual derivative. Okay, so it's a little bit of practice. It can be pretty straightforward. All right, so if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. Okay, so let's say for this example, let's say if h of x is equal to f of x over g of x, where f of x is equal to negative 5 cosine of x. And g of x, let me bring that down a little bit so it's not all running together, and g of x is equal to x to the third power minus 2x squared minus 4x minus 1. What is h prime of x? Okay, so basically all they're asking is, what's the derivative? Okay, it'll be worded different ways. It may look like this. It may actually say find the derivative, but it's really the same thing. Alright, so we know our quotient rule for derivatives looks like this. So if h of x is f of x over g of x, then h prime of x is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Okay, so that's our quotient rule. I don't know why I put an S on there, but quotient rule. Alright, so we're going to go ahead and apply that quotient rule to this one. Okay, so we know here our h of x is equal to f of x over g of x. So our h of x is equal to negative 5 cosine of x, since that's our f of x, over g of x, which is x to the third minus 2x squared minus 4x minus 1. Okay, we can go ahead and find the derivative of that. Okay, so that means your h prime of x is equal to the denominator. Remember, the denominator times the derivative of the numerator. So the denominator is x to the third. Let me move that up just a hair. X to the third minus 2x squared minus 4x minus 1 times the derivative of the numerator. So the derivative of negative 5 cosine of x minus, the numerator. So that's negative 5 cosine of x times the derivative of the denominator. So you have the derivative of the denominator, so x to the third minus 2x squared minus 4x minus 1. Oh, running out of room there. All over your denominator squared. So you have x to the third minus 2x squared minus 4x minus 1 squared. I know that's quite a handful to write. So your h prime of x is equal to, you have x to the third minus 2x squared minus 4x minus 1 times the derivative of negative 5 cosine of x. The derivative of cosine is negative sine. So you have negative 5 times negative sine will end up being a positive 5 sine. Okay, so that's times 5 sine of x minus negative 5 cosine of x times the derivative of x to the third minus 2x squared minus 4x minus 1. Okay, so for our x to the third power, we'll bring down to 3, so that's 3x squared minus, bring down that 2, so that's minus 4x. That ends up being minus 4, and the derivative of a constant negative 1 is 0. Okay, so that's all over our denominator squared, which is x to the third minus 2x squared minus 4x minus 1 squared. Okay, so really, even if we distribute these, there's nothing you can actually combine. So we're going to leave this pretty similar to where it is up here, just kind of simplify that. So you have x to the third minus 2x squared minus 4x minus 1 times, actually I can bring that out to the front, that 5 sine of x. Look a little awkward being behind it. So you have 5 times sine of x times x to the third minus 2x squared minus 4x minus 1. Yeah, it looks a little bit better. Minus minus is plus, so that's plus 5 cosine of x times 3x squared minus 4x minus 4 all over your denominator squared, which is x to the third minus 2x squared minus 4x minus 1 squared. All right, and that would be your final answer for that one. Okay, so hopefully this made sense, and I will see you on the next video.